Hi, I can barely see you guys here. So I'm so glad to be here, and I love this conference, and it has so many diverse set of topics. Today, I want to tell you about on the technology side, so particularly on AI everywhere through hardware and software accelerators. Before I start my talk, we want to show you a video first. So please roll the video.
We know where we need to go, but we can't get there on our own. We need crops that anticipate climate change and are immune to disease. The elderly as flexible as teenagers, and minds sharp well into old age. Technology that anticipates our intentions and saves hundreds of hours of menial tasks. Insights that elevate the performance while mitigating the risks. We know where we need to go, but we need artificial intelligence to get there. Healthcare needs AI for real-time insights into the human body. Sports needs AI to achieve new feats and set records. Exploration needs AI to decode the mysteries of the universe. Artists need AI to push the boundaries of creativity. At work, on the road, near home, out in the field, under oceans, in the air. We need AI everywhere.
So you have seen many AI applications, and I'm so excited to see we have applications in many different domains, all the way from healthcare, financial services, and entertainment even. So that's happening today already. Tomorrow, we will see even more AI applications. And in the future, we will see AI everywhere, accelerated by hardware and software. Now, today, all of you probably have seen data increasing exponentially in your companies. And we have many AI ideas already. And in the research community, people continue to push the boundary of cutting-edge AI ideas. And all of us may have different ideas to apply AI in many different areas. AI will take data and give us insights. Now, let me do a simple survey here. Raise your hand if you are able to turn your AI ideas into production easily. I've seen one hand, okay. Two. Okay. Now, I agree with you. In the recent research, it showed that 87% of AI ideas fail to become reality. And that's because AI today is very complex, particularly in the production environment. There are many research papers being published, but it takes a long time to go from research to production. There are many reasons for this. Sometimes our data is very much siloed. In your company, you may have different departments. Each department may have their own databases. And sometimes the AI solutions may be siloed also. There are different AI solutions. It will take multiple solutions to get you the AI solution you're looking at. And sometimes the machines are just not fast enough. And sometimes all of us are domain experts. We are good at what we do, but we are not necessarily AI researchers. So what we need is to have a bridge from data to insights. And this is a picture of Golden Gate Bridge. I happen to live in the San Francisco Bay Area, so I really enjoyed crossing the Golden Gate Bridge. It's just beautiful there. And more so, when I bike across the bridge, that's even more beautiful. Now, what does that mean for AI here? Recently, we've been working with a pharmaceutical company called AbbVie, a leading pharmaceutical company in the US. And they are in the business of drug discovery and drug development. As you may know, it takes a long time for a new drug to be developed, to go from the bench to the bedside. It takes more than 10 years, multi-billion dollars. So they are very motivated to use AI to speed up the drug discovery process. And they have a lot of data. So the AI problem is very large and requires a lot of computation, requires a lot of memory. Now, at Intel, we do provide a lot of hardware, as you may know. We have a lot of servers, and you can have a cluster of servers with a lot of compute, a lot of memory for this. Now, the state of art on the software side is it requires multiple software packages you have to stitch them together to get a solution. And these packages are not necessarily scalable when you look at a large amount of data. So then we worked with another startup company called Katana Graph. It's a software company. Between Katana Graph and Intel, we have created a set of software packages, an entire pipeline, so you can seamlessly optimize and make it work for large amount of data on a larger cluster to solve problems like this. So that's what I meant by software, hardware together to bridge the gap from data to insights. Now, I'm in Amsterdam. As you know, there's so many different bridges. So one bridge obviously is not enough. And on the AI side, one bridge is not enough either because we have so many different problems we're trying to solve here. So we need domain-specific solutions as well. So what we are doing at Intel is we're building an entire stack, entire infrastructure for AI. And that infrastructure, we have a goal of two things here. One is we want to provide the fundamental performance for this because AI problems tend to be very big. So you need performance to process large amount of data. And then the other is simplicity. We want to make sure the developers can get their solutions easily, which is not the case today. So let's look at the overall entire stack here. At the top of stack is a set of solutions all of us want to develop. And in the second layer of the stack is where we build a lot of software tools or blueprints to make it easy for development to happen quickly. And then the third layer is when we have the performance libraries and the frameworks optimized so we can run these things, run models much, much faster on the platforms. And at the bottom layer, we have hardware. So let me look at each layer by looking at the bottom layer first. So on the hardware side, within Intel, we have a rich set of portfolio. We have AI acceleration on all our product lines here, all the way from CPU product line to GPU product line to special AI accelerators. And then what's in common here is when you think about AI today, much of this is deep learning. Deep learning comes down to matrix computation. So we have matrix unit for each of these pipeline, or each of these product lines. Even CPU has matrix unit in our next generation of Xeon server called AMX, Advanced Matrix Unit. Now let's look at the second tier, which is the library and the framework side. Let me give you one example. This is the work we've been doing with Google on TensorFlow. So our software strategy has two prongs. One is we want to enable the entire ecosystem on our platforms. And then the other is we're building a lot of new software ourselves. So this represents our contribution to TensorFlow. And I'm glad to share with you that in TensorFlow 2.9, which released a few months ago, the optimizations my team has been working on, including the library called 1DNN, have become default inside TensorFlow. So that means you can just download TensorFlow. You don't even know what's inside TensorFlow. You get the performance benefit automatically. And we have measured 3x performance gain by using the additional optimizations we have made default. Now, in addition to improving our platforms, we also have contributed to the TensorFlow ecosystem by improving TensorFlow for multiple architectures. You may find it interesting to see ARM is on the list here, because in TensorFlow 2.10, they also improved the performance on ARM by going through the one API interface Intel has designed. So by contributing to 1DNN library that my team has been working on, TensorFlow has been able to improve performance on ARM as well. In addition to that, from TensorFlow 2.10, Intel has taken over the ownership of Windows build for TensorFlow. So we become the owner for Windows build. And this is interesting because if you think about AI everywhere, we need to do well on Windows as well, because a lot of the computers are Windows-based computers. Now let me look at the layer on top of this, which is the toolkits and blueprints. So let me give you one example of what we've been working on with our partner, Accenture, recently. In July, we launched 4 reference kits, and 2 weeks ago, we launched another 5 reference kits. Now, why are these reference kits interesting? As I said earlier, at the bottom layer, we want to improve performance. At the top layer, we want to improve productivity. We want to make it simple for people to develop AI solutions. So reference kits are the first step we make one of the steps we're making in that direction. And these reference kits are designed for different use cases. As you can see, it goes all the way from things like chatbot. If you want to have a conversation, we can have a chatbot here, to something like healthcare. And all the way, you can see there's a credit card fraud detection reference kit as well. So depending on what problem you want to solve, you can have a variety of different reference kits here. And let's show you one of the reference kits just to get a taste of how that works. So this is the disease prediction reference kit. The input to the disease prediction reference kit is a set of symptoms. So if you're a patient, you go in to see a doctor, you tell them what kind of symptoms you have. And then the reference kit will tell you the probability of variety of diseases these symptoms may be part of that. And within the reference kit, we have the data set for you to train the model. And we also have the model itself. So in this particular case, we adopted the clinical BERT model developed by MIT. And then on top of this, we also have included many technologies. Some of these technologies are from my team. For example, Intel extension to PyTorch, and Intel neural compressor. And some of these technologies come from the ecosystem. For example, Hugging Face. So how do you use this reference kit? So they may have multiple scenarios here. For example, if you don't have a solution for disease prediction, you can start with the reference kit basically as a starting point. And you can modify it, you can use your own data to train this. Or you may already have a solution for disease prediction. Then in that scenario, you can still look at the reference kit and see how the reference kit is constructed. And then because the reference kit has all the optimized tools we have developed, it can improve performance very significantly. For example, 50 53% all the way to 69%, where you can improve your inference time in a meaningful fashion. So there are many different ways of using it. You can use it as is, or you can use it as different components as a guide to improve your current solutions. Now, at the solution side, I already showed you quite a few solutions at the beginning in the video. Many of these applications in that video actually are accelerated by our software and hardware. With our software and hardware, there are more people using them to do something they never imagined before. For example, space exploration. And this example of FDL, which is a company started from NASA and a few other partners. And they're using Intel technology to do space exploration. And my team is also working with many other partners, for example, Stanford University on heart surgery to make sure the heart surgeons can get help from AI. Now, what I have shown you is a few examples at each layer. And what we're doing here is much more than these examples. So this is a little bit bigger set of technologies we're developing inside Intel. And for each layer, you can see there are many different things here. So at the top layer, many customers are adopting our technologies to solve their problems here. For example, you can see MasterCard, Leica, and AbbVie, Azure. There's many enterprises as well as cloud service providers integrating our technology inside their services. And in addition to that, when we look at the toolkits, I mentioned the reference kits. These are use case-based reference kits. But on top of this, we also have domain-specific reference kits, domain-specific toolkits. So for example, if you want to develop privacy-preserving machine learning, we have a toolkit specifically for that, and to make it easy for you to develop applications on top of this. And if you want to develop machine learning models on time series, we have a domain-specific toolkit for that as well. At the library framework level, we have done work not only for TensorFlow, but also other frameworks such as PyTorch. So Intel optimizations like 1DNA, and they have been default in PyTorch for many years, since 2018. And we also worked on other popular frameworks such as XGBoost and Scikit-learn. Now, to summarize, today, AI is very complex. We have 87% of ideas never made it to production. Tomorrow, we want to help make the dream come true, which is 100% success. Every one of us, once you have a new idea, you can easily develop AI solutions from that. And that's our goal. We want to bridge the gap and make AI everywhere with both software and hardware. And if you are interested in additional information about what we do at Intel, I have two URLs here. One is ai.intel.com, which has a broader set of products. And if you're interested in specifically on the software side, we have developer.intel.com/AI. So thank you. A few seconds ahead.
Wei Li, thank you very much indeed. Very insightful presentation.